All right, tonight's you guys were working on your triple point diagram. So the first question was, when a substance melt, what happens to the motion of the molecules of the substance? And the idea here is that if I look at this, this is the point at which it melts, and well, right up on the blue line actually, over here. So that point at which the substance melts is when the particles don't move faster. They just spread out and aren't as attracted to one another. Well, probably because, and not lined up. So, and I showed you that in this, is that when it's a solid here versus when it's undergoing a melting point, the energy is being used to move them so that they're not as lined up. Okay. Second question says, what is the freezing point and boiling point of water? Well, if I look and I follow this line here, if I follow this black line right here, it stops right at 0. And it goes all the way down, all the way to 100. So at 0 degrees Celsius and 100 degrees Celsius. So what does lowering the pressure affect the boiling point? Well, let's take a look. Let's say I lower it to 0.1. The boiling point now is 75 degrees Celsius. So as I lower pressure, as the pressure goes down, the boiling point also goes down. And then I just did that part. 75 degrees Celsius is right there. The triple point of a substance is when all three are possible, and that point is right there. And let's move this diagram up over here, and let me clear the ink real quick. Okay, so in the question number 6 says, dry ice sublimes, that is, changes directly from a solid to a gas. Is it ever possible for it to be sublime? Yeah, I mean, if you look here, this is going from an ice to a vapor right along this line. So long as it's in there. So it's got to be below this point. So I would say it's probably below maybe less than 0.005, it looks like, or so. ATMs? It'll happen. No matter. And then the temperature is going to be below 0 here. Okay. What is meant by the vapor pressure of water? In here, what that means is just that water is constantly evaporating, so it's the pressure given off by the fastest moving particles escaping to the gas phase. Number 8, from the phase diagram, estimate the vapor pressure of water at 25 degrees Celsius. And so at 25 degrees Celsius, vapor pressure would be right here. And that would be approximately 0.01 atm. And then estimate the vapor pressure. Oh, sorry, that one was for number 8. What is the vapor pressure of water when the temperature is 100 degrees Celsius? Well, that is 1 atm. Question 10, when the atmospheric pressure equals 1 atm, what is the boiling point of water? That is 100 degrees Celsius, and this should say from 9 and 10. Formulate a definition for the boiling point. It is when the atmospheric pressure is equal to the vapor pressure. So in other words, the air particles that are outside are equivalent to the particles getting out from the water. And that's what we call boiling. Is it ever possible for solid H2O to exist at temperatures above 0 degrees Celsius? And the answer there is yes. Above 25 degrees Celsius. So here's 25 degrees Celsius. And the only time that that ever happens, oh, I'm sorry, a solid, wait, for solid water to exist at a temperature, that is at low pressures. And then above 25 degrees Celsius, this one is no. So 0 degrees Celsius, you can still be a solid, but the pressures have to be below this and this. But for solid H2O to exist at a temperature above 25, no, it's not possible, because above 25, you can only be a liquid or a vapor. There is no solid over here. Let's clear this, and then let's move this up. And then question number 14. Describe the region where a solid-liquid equilibrium exists. Well, that looks like right here, and we call that solid equilibrium the melting point. And then, why might an equilibrium situation be described as a reversible change? Well, you have just as likelihood when you're at these melting point, or if you're at over here, the boiling point, or if you're over here and you're at the sublimation point, you have just as good of a likelihood of being a vapor or a liquid, or ice and a liquid, or ice or steam. So you have just as great a likelihood. So you could reverse it depending upon whether you're either adding energy or taking away energy. It's the same idea behind why the melting point is the same thing as the freezing point. Those two things mean the same thing. It's just the difference of whether you're either taking away energy or adding energy. I hope that helps. I'll see you tomorrow.